we're going to talk about how to write an equation in vertex form. Remember that vertex form, y equals a times the quantity of x minus h squared plus k, is called vertex form because we can figure out the vertex just by looking at it, right? H is our x value, k is the y value. Remember, you change the sign for h and then you keep the sign for k. So if we were given our a value and our vertex, right, letter A, they gave us our a, our h, and our k. That's everything we need to write this equation. Y equals 2 times x minus 1 squared minus 3. Notice that h was positive, so I ended up subtracting it, and k was negative, so I also ended up subtracting it. You change the sign for h, you keep the sign for k. It'd be a good idea to pause and try B and C. Well, B, a equals 1, and then h is negative 4 and k is negative 4. Well, since h is negative 4, I'm going to end up adding 4 because I changed the sign, and then I subtract 4. I don't actually have to have the 1 there. This is the same as y equals the quantity of x plus 4 squared minus 4. Last but not least, a is negative 0.5, h is 2, k is 0. So we could write this as negative 0.5 times the quantity of x minus 2 squared plus 0. But if we add 0, that's not really going to change anything. Also, note that we could write this as a fraction instead of a decimal. So these are two different ways to write the same equation. Now, we're going to do that same thing, but we're going to have to pull this information from our graph. So let's try that. We're looking at our graph, and we want to be able to write the equation in vertex form. Well, we can start off by finding the vertex. Here's my vertex, right in the middle of my parabola, and it looks like this is the point 4, negative 3. So h is 4, and k is negative 3, which means if I think about substituting this in to my vertex form, look at that. We have our h and k value. All we need to find now is a. The only way to find the a value is if it's the only variable. Right now we've got an x and a y and an a. So in order for a to be the only variable, we have to pick another point. This can be any point at all. It's just got to be something that's on the parabola. So if I look for a nice point, let's see, here's a nice point, here's a nice point, here's a nice point. When we say nice point, we're saying integers, right? Integers are accurate, and they're the easiest to substitute. So I'm going to pick this point 2, 1. Again, I could pick any point on the parabola, but 2, 1 is the point I'm going to use. So this gives me an x and a y value, which means we can plug in y for y and x for x. So this is going to look like 1 equals a times x minus 4 squared minus 3. Notice that a is the only variable now, so we can solve for it. These two steps are basically the same step. So we're thinking about our order of operations. So I'm going to simplify my parenthesis and my exponent to start. So I know that 2 minus 4 is negative 2, and I know that negative 2 squared is 4. I could also write this as 4a. Well, if 1 equals 4 times a minus 3, that's just a linear equation. I can solve that using inverse operations. I'm going to add 3 to both sides. 1 plus 3 is 4, equals 4 times a. If I divide by 4, I find that a equals 1. Now we have everything we need to write our vertex form. So if we put this all together, here's my hk, here's my a value. So our equation is y equals 1 times x minus 4 squared minus 3. There's our vertex form. So in order to write vertex form as an equation, all you need to do is find hk and then find a by solving. Let's try again. It'd be a good idea to pause and see if you can do this one on your own. So again, we want to figure out the vertex. Well, here's my vertex. This looks like it's the point 4, 1. we're already halfway done. Here's my h, here's my k. Again, I like to write it down so I know what I have and what I'm looking for. I still need my a value. And I could pick any point I want. It's just got to be a nice point. I see a couple nice points. I'm going to pick this point, 3, 3. That gives me my x and my y value. So if I substitute those in to my equation, now a is the only variable. And that's why I can solve for a, when it's the only variable. I was never going to be able to solve for a when I had the x and the y in there. So order of operations, I do my parentheses first. 3 minus 4 is -1. -1 squared is a positive 1. And again, a times 1, I could write that as 1a, which is just a. And now I have a linear equation. So I could do my inverse, subtract 1 to both sides. So I see that my a value is 2. Well, I found h and k, I found a, so I put this all together, and the vertex form is y equals 2 times x minus 4 squared plus 1. Perfect. Let's do one more example. It'd be a good idea to pause and to try this last one on your own. Notice that this one doesn't have the prompts, so we just have to remember what to do. Well, we always start off by finding that vertex. Here's my vertex. This is the point -4, +3. -4, +3. So there's my h, there's my k. So I'm going to write this down so I can see what I know and what I need to find out. The sign for h flips, so this becomes a +4. The sign for k stays the same, so it's going to be a +3. Well, I'm halfway there. I need to find a. So again, that only works if I can have a be the only variable. So I'm going to pick another point. Doesn't matter what point I pick. I'm going to pick the point -2, -1. -2, -1. Here's my x value. Here's my y value. When I substitute that in, it will look like this. And then I can use my order of operations. Okay. Well, -2 plus 4 is a +2. And let's see. I know that 2 squared is 4. I know that a times 4 is just 4a. Now I can use my inverse operations. I'm going to subtract 3. So I get -4 equals 4 times a. And when I divide by 4, I find that a is equal to -1. I have my hk, I have my a value, so if I put it all together, y equals -1 times the quantity of x plus 4 squared plus 3. And there is our vertex form for this quadratic. So again, vertex form, pretty straightforward. You identify your vertex, that's your h and k, and then you pick another point to use so you can solve for your a value.